You know about containers and you know about Docker as well. You've probably even gone ahead and used Docker to create your own custom containers or test out some applications or a number of different things that you might have tried it on. If you don't know either about containers or Docker, then what are you even doing here? First, go and learn about those two technologies and then you can come back to this video. Now, after you've created your containers with Docker, what next? When you want to deploy it to production, you want to give your application to the whole wide world out there. You want them to use it. And you want many people to use it. Maybe thousands, maybe hundreds of thousands, maybe millions of people. Docker falls short when you try to do that. Because of its own technical limitations, it can't scale up to 100,000 or even a million users. You can use inbuilt Docker features to go up till maybe let's say 50,000 users. But after a certain point, it's going to have a lot of problems with scaling. So that's where we have Kubernetes that comes in to solve this problem. Now, what is Kubernetes? How does it work? We're going to be having multiple videos where we're going to talk about Kubernetes, its architecture, its components, how each and every single components work, and in the end, how they all work together as a single unit for making all of the deployments, scaling those workloads, and basically just servicing your application to millions of users. So today I'm just going to be talking to you about Kubernetes, what it's used for, and its architecture. So I'm just going to touch briefly over all of its different components and what each one of those components is responsible for. So let's go ahead and get started with that. So the very first thing which you need to know, Kubernetes is a container orchestrator. Now, what exactly does that mean? Let's say you've got three different containers. One of these containers contains the front end of your application. Another one contains the back end. And another one contains the database. Now, for 1 second, just forget about containers. How does this whole application work? You have a user. Your user, first of all, comes over to the front end, right? On the front end, they will see your entire page where they have to click and all of those different sort of things. Now, let's say they click on a login button. What happens then? The front end sends some sort of information to their backend server, right? The backend server does some sort of processing. Your user is trying to log in. So they will enter their password, they will enter their username, and they will hit login. The request goes to the backend server. The backend server is going to check with the database whether those credentials that you provided through the front end are correct or not. Then the database will send it back to the backend, and the backend will send the information back to the front end, whether the request is successful or not, right? This is your traditional architecture. Now, this whole application, it's bundled into one single application, right? So this entire thing is just one single application. Now, when we try to do this with containers, we have something called as microservices. So that means the backend, the database, and the front end are all going to be their own separate applications. So the front end is one standalone application, backend is a standalone, and even the database is a standalone application. That's how a microservice architecture works. So in practice, this box is simply your containers, your Docker containers, and you use some networking features to link all of these together. So for example, within your front end code, you will say that my backend request has to go to this particular IP address on this particular port. That's how your whole microservice architecture works. Now I'm talking about microservice architecture because Kubernetes as a whole was designed for handling these distributed microservice workloads. Slowly this will start making more sense to you, but for now just understand microservice applications means breaking down one big application into multiple smaller subsections. So we went on this little bit of a tangent about microservices to understand what Kubernetes does. So basically all these microservices are individual containers, and it is Kubernetes' job to manage all of these containers. So it's going to handle how your front end will talk to the back end, how the back end will talk to the database, and how all of these different things are going to go ahead and scale. So now let's go and look at the actual architecture of Kubernetes. So I'm going to start from the very top layer, and then slowly we're going to keep moving down. If you want the whole diagram about how it works at the end, you can go to k8s.io and check out the Kubernetes components page. There's this entire diagram about how Kubernetes works. And the documentation is quite amazing, to be honest. You can just go ahead and refer to it at any time for any particular component that you're having a confusion about. It's really good. So starting from the top, the very first thing which we have is called as a node. A node is simply one single virtual machine or a physical machine if you want to make a cluster of a lot of physical devices. So for example, let's say that I've got 5 different laptops and I want to create a cluster out of those 5 laptops. Each laptop is going to be one single node. Similarly, it could be virtual machines as well. You could have 5 different virtual machines. One virtual machine will be one node. So within Kubernetes, you usually have 3 nodes. Now I'm just going to take an example with 3 nodes here. So even these nodes have got 2 different types of nodes. One of them is called as the control plane or a master node. And the second type is called as either the worker node or the slave node. I'm going to use the most up-to-date terminology. So I'm going to be calling it control plane node and worker node. Among these 3 nodes, let's label this one as the control plane. Now, what exactly is the job of the control plane node? The control plane node is going to house all of the core components of Kubernetes. So you've got about 5 to 6 different components which actually run Kubernetes. These 5 to 6 components will exist within your control plane node. The second type of node is the worker node. So this other 2 nodes, I'm going to label them as worker nodes. Now, whatever application you actually want to deploy, let's say you have an e-commerce website like Amazon. It's going to have its different components, right? It will have its own front end, its back end, its authentication service, its searching service, and whatever else. That is your entire application. That application, you will deploy it into your worker nodes. So a quick TLDR summary. Control plane nodes houses all of the core components for Kubernetes. Worker nodes will house your applications, your databases, your front end, your database, your back end, etc. Now, every single component in Kubernetes has some sort of a logo. Now, this is the logo of the control plane. This is the logo of the worker nodes. And every single component which I'm going to talk about, I will be using its logo. The very first core component of Kubernetes that I want to talk to you about is called as the Kube API server. API server is basically the central point of communication within your entire cluster. So whatever commands you run, whatever information you send to Kubernetes, for example, you tell Kubernetes, hey, I want to deploy this Nginx application. That information is going to first go over to the API server. The API server is going to make sure that the security is in place, an unauthorized user isn't making the request, you're doing exactly what you're allowed to do. All of those type of things, the API server is going to make sure of it. Once the API server has the request that, okay, such and such person is asking me to create this application of Nginx, the API server will not do it itself. It will go ahead and tell one of the other core components that, hey, I want you to go ahead and do this particular thing. The next Kubernetes component I want to talk to you about is the controller manager. The controller manager is basically going to handle all of the controllers within Kubernetes. Now, what exactly is a controller? Let's say that you have got two instances of a particular application running in your worker node. Now, just to run these two applications, there's going to be some entity on top. I'm not getting into the specifics of what this entity is. Just know that there is something above your application which is controlling them. What does it control? It makes sure that the application is running smoothly. If the application goes into an unhealthy state, it is the job of this component to bring it back online. Now, this component is controlled by its own controller. So Kubernetes has got a ton of controllers. I think there are around 56 controllers in total that control different aspects of Kubernetes. Now, if you were to go ahead and try to control all of those 56 ones individually, it's going to be a headache, right? If one of those controllers goes down, you're going to have to individually find what's gone down and bring it back up. So that's why we have the controller manager, a controller of the controllers. So if any of those other controllers goes down, the controller manager is going to make sure to bring them back up. If any of them do not recover, we know that something is wrong with the controller manager itself, and hence we just have a single point where we need to debug. Now there is actually one more type of a controller manager, and this one is called as the cloud controller manager. Now I'll just touch upon this in a few small details because in a local Kubernetes cluster, this is not really going to be relevant. If this whole Kubernetes cluster was deployed on a cloud provider such as AWS, and for whatever reason you want to add an extra node to your entire cluster, how are you going to do that? If you had to do it manually, you would first go ahead and provision an EC2 instance. You would put your essential components within it, and then you would connect it to this cluster. But that is a manual process. You don't want to go ahead and do it manually. You want to automate that process based on certain conditions. So that's where the cloud controller manager comes in. This CCM will be connected to AWS's API. So you can just give the instructions to the CCM that, hey, I want to go and connect another node to this cluster when XYZ conditions are met. And the CCM will go ahead and take care of that. TLDR version, the CCM controls everything that the cloud provider contains. So the cloud resources are controlled by the CCM. The next component is called as a scheduler. What does the scheduler do exactly? The scheduler simply handles where should a particular application get scheduled. So we took this particular application here, for example. Now let's say I have just given the instruction to create this application, but I have not told it where to go exactly. So it's going to be the scheduler's job to figure out where to put this, whether to put it in control plane, whether to put it in this first worker node or in the second worker node. The scheduler is going to determine that on a number of different factors. Number one is your system resources. So does this particular worker node have enough CPU, enough RAM to run this application here? That's the main thing. Second thing, you can configure particular rules that tell the scheduler that, okay, this application should not be placed here. It should only be placed here. And if you cannot place it here, do not place it anywhere else. Those are certain rules which you can use to configure the scheduler with. We'll look at those rules when we take a deep dive into the scheduler. Now, one last component of the core Kubernetes architecture is the HCD. So the HCD is basically a database. How you have Redis, how you have MongoDB, Postgres, etc. HCD is the exact same thing. Nothing different. The only difference is that HCD was designed in a way to specifically work with Kubernetes. It's just a simple key value store, which is going to store all of the information that happens within the cluster. So for example, I tell the API server to schedule something. That information is going to get stored in the HCD. The scheduler goes ahead and puts it in the second worker node. That information is going to get stored in the HCD. Maybe the application has some error for whatever reason. It goes down. That information is going to be stored in the HCD. So it's basically like a library record. You know, in a library, right? You take out a book, you borrow it. The librarian makes a note in their diary. So it's a complete record. HCD is the exact same thing for Kubernetes. It's a record. And you use HCD for creating backups as well. If you lose this HCD, if HCD goes down or gets deleted for whatever reason, you have basically lost visibility into your entire Kubernetes cluster. We'll touch a little bit more about that after we've covered every single component. There are just 2 components left within Kubernetes. Let's quickly take a look at that and then see how all of them work together. What you can see here is Kubernetes, but it's not going to work. Why is it not going to work? There is absolutely nothing that's enabling communication between all of these different nodes. Forget the nodes, even within the same node, there is no way for the API server to talk to the control manager or scheduler or anything to talk to HCD either. So for that, we need to first bring in something which is going to connect every single component in the cluster together. This component is called as a kube proxy. So the kube proxy is going to exist in every single node of yours. The kube proxy is what's going to enable the communication between the entire cluster. So because of the kube proxy, the control plane can talk to the worker nodes, both of the worker nodes. All of the components within the control plane node can talk to each other because of the kube proxy. The kube proxy is basically like your telephone company. It enables communication between the different nodes, between the different computers, and within the different components within a single node as well. Now, the final and most important component in a Kubernetes is called as a kubelet. And just like the kube proxy, the kubelet is going to exist in every single node within your cluster. What exactly is a kubelet responsible for? You have your HCD application. You have your control manager application, the API server application. Who's going to be responsible for building the containers of these applications? That's going to be the job of the kubelet. Every single component that you see over here, whether it's the API server, the controller manager, the scheduler, all of them are containers. They're all applications running within containers. It's the job of the kubelet to talk with these containers, create those containers, manage them. If something goes wrong in those containers, they go down for whatever reason, it's kubelet's job to bring them back online. So kubelet is basically responsible for creating all of the containers and managing those containers. It's basically like the builder of the cluster. Alright, so we've covered all of the components within Kubernetes. Now I'm going to talk to you about how they all actually work together. There are actually a few lower components as well, but I'm not going to touch on them right now. Right now, I just want you to understand the high level architecture. The lower level components such as pods, deployments, replica set, services, I will cover those in another video. For now, don't worry about what any of that means. Right now, I just want you to try and understand how this whole architecture works together. So I want you to first know about this one thing called as kubectl. kubectl or kubectl, however you want to pronounce it, is the CLI tool with which you will talk to a Kubernetes cluster. Now, using the kubectl tool, you will give information to your Kubernetes cluster, whether you want to create a new application, you want to create a new authorization feature or an authorization rule, you want to create a new networking rule, etc. You will use kubectl for all of that. As a system administrator, if you're a developer, there is a direct API as well to directly talk to Kubernetes API and then go ahead and do all of that work. But for all intents and purposes, while we're learning Kubernetes, we're always going to be using the kubectl. Maybe down the line, we'll look at how we can use the API as well to directly talk to the API server. But for now, it's only kubectl. Okay. So how does this whole Kubernetes architecture work? First, you have kubectl. Now let's say that I want to go ahead and create 3 instances of an application called as Nginx. Nginx is a web server. So it handles things like load balancing and everything. If that doesn't make sense to you, don't worry. We'll talk about it later on in a different video. So for now, let's just say we are creating 3 instances of an application called Nginx. I pass in the command through kubectl. I'm not talking about the exact command right now, but I just say, hey kubectl, please tell Kubernetes to create this Nginx application. What's going to happen after I press enter in my CLI? kubectl will first send the message to the API server. Okay. The API server is first going to make sure that wherever this message is coming from, they are an authorized user. They have the correct permissions. They are not some hacker who is not within the permissions list, right? It's basically ensuring all of the security features, such as you've got the correct permissions. You can actually create this. You have access to do this. You're authorized to do this, etc. All of those different things. The API server will read this and it will say, and then it is going to send that particular information that this application needs to be created. Please go ahead and create this application wherever the particular rules are satisfied. So the API server will send that information to the scheduler. Then the scheduler will go ahead and check both the worker nodes, that who has got enough system resources. Let's say that worker 1 has got the proper conditions met. Worker 1 satisfies all of the required conditions. So the scheduler is going to go ahead and create a deployment. A deployment is simply one of the components of Kubernetes. Don't worry much about what exactly it is. I will cover it more later, but just understand the whole process. The scheduler will go ahead and create the deployment, and the deployment will have one extra layer below it called as a replica set. Don't worry about that. And then the replica set will finally create the 2 pods. Now, even in this, there are a couple of steps. Once the scheduler creates the deployment, this deployment is now going to be managed by the deployment controller. Let's just say this right here is the deployment controller. This will manage the deployment, and this deployment controller gets managed by the controller manager. Now the deployment will go ahead and create this replica set, and this replica set will control these pods. For example, this pod goes down, go ahead and start it back. And the pods are actually going to be created by the kubelet. And how is this whole communication happening between all of these various components? That's happening with the kube proxy. Now these pods have been created, these containers have been created. All that information that a request was sent to create this particular application, the application got scheduled on this particular node, all that information is going to be stored in the etcd. The etcd will just have a complete store of all of this information. All right, cool. I hope that makes sense. This does seem a little complicated, and I won't lie to you, it is a little complicated when you see it for the first time. But once we go ahead and do hands-on and we visualize exactly what's happening during the hands-on, it will all start making sense. So now we understand the whole architecture of Kubernetes, and now you're ready for doing hands-on. I'm not going to do hands-on with you right now. First, I want you to take some time and just absorb all of the information I just gave you. Maybe watch this video a couple of more times just to understand everything that is happening. Understand every single component and its functionality. And in a couple of days time, we'll go ahead and do some actual hands-on within Kubernetes. So we'll be using kubectl, we'll be creating our own applications, and at the same time I'm going to help you visualize exactly what is happening so you have absolutely zero confusions left. So really excited to do that with you, and see you all in that video.